Okay, so there will be part of this presentation that might be a repeat from sessions yesterday, but that's the intro that sets the context. So if it's a repeat, sorry for that. But then obviously there will be some more. We will go a little bit more in the details. Okay, so first question is, why did we do Zeno? Okay, and the answer is this horrific picture, which resembles to the system that, in our perspective, we are building today, right? Because when you try to build a system that spans from a microcontroller up to a data center, that is what you end up with. And a digital Frankenstein. So integrating multiple technology only to communicate, and eventually, if you want to deal with data at rest, it's even worse. So a similar situation, as we were discussing yesterday with some of the attendees to the Eclipse Day, happened in the early days of the DARPANET, or the ARPANET, when there was a proliferation of protocols that were used on the different campus networks or corporate networks like BBN or Stanford versus Berkeley. And they were actually deploying, this is the original paper, so unfortunately the resolution isn't very great for the picture. They were deploying gateway to integrate all of those different protocols, which is essentially what we do today, right? And it was becoming very problematic to the point that at some point they said, man, we need to solve this problem. We need to have a protocol for interconnecting networks, so the inter-networking protocol, and IP was born as indeed a protocol to connect heterogeneous network. But in the end, IP became the protocol that ran on those networks and let the internet become, I think, what is the internet today. And it's interesting because, as I was remarking yesterday, the IP protocol was an inter-networking protocol, right? It wasn't necessarily addressing local area network. It was for interconnecting heterogeneous network, but we are running now everywhere, and it runs sufficiently well. So the question is IP the answer? Well, not quite, because as our applications are more and more data-centric, right? So usually, we try to hide as much as possible the fact that eventually there is an IP address somewhere, and we always deal with data and named data, right? So we've built a bunch of protocols that give us higher abstraction that are more data-centric and help us supporting our application, and that is the proliferation that is leading then to those kind of heterogeneous situation and necessary integration, okay? So I will jump immediately to Zeno. I will, in real time, kind of change the order of the presentation. And let's jump immediately to Zeno. So as we briefly saw in the previous session, right, Zeno is a protocol that was designed ground up from a team that had seen those sort of things. We have been in protocol for more than 20 years and took up the challenge to try to design a protocol that could really run from the microcontroller up to the data center and remove all of the constraints that exist today, right? Because you have topological constraints, you have applicability constraints, and so on and so forth. The other problem that we saw, especially when systems were trying, were growing in scale and trying to leverage edge intelligence, was the availability of data on the edge. So the ability of maintaining data at rest while ensuring location transparency. And I think one of the advantages of Zeno is that we managed to blend the state-of-the-art pub/sub and state-of-the-art NDN protocol, so named data networking protocol, into a single integrated protocol. Okay, so we took the concept from the two family, put them together, shake a little bit, sweat a lot, because we didn't get the right abstraction at first. So I was mentioning in my previous talk that essentially we have three abstractions: publisher, subscriber, and queryable. As we will see, we had more before. And you always have to try to remove primitives as opposed to add and make sure that they're orthogonal. So once we get to the abstraction, I will tell you how many we had and why, and how we did realize that in fact that was not minimal. And by the way, the other big news is that one of the versions of our protocol, the version that targets microcontroller, which still is a full implementation of the protocol, I will tell you what are the limitations, is being certified ACLD. So that's also going to go toward automotive and the safety critical portion of the automotive. So where does this protocol sit? So this protocol can sit as low as a data link and you see it reflected on the kind of transport that we support. So we can run on shared memory, Unix socket, Bluetooth, serial, as well as UDP, TCP, and QUIC, because potentially we can run on transport network on data link. All the infrastructural elements of Zeno are written in Rust. 90% of our code is written in Rust. Then, as of today, we need to target embedded device with C for 2 reasons. Certification, we couldn't do, unfortunately today, ASIL D in Rust, maybe in a couple of years. Actually, you cannot even do easily, you cannot do even ASIL B today in Rust, but we are getting there, hopefully soon. So certification is one aspect, and the second is that when we started Zeno, at least rewriting Zeno in Rust a few years ago, embedded Rust wasn't, in our perspective, so mature in terms of ecosystem. It's much better now, huge contribution from Red Hat in that area. So we are converging, but we still target deeply embedded with C. That's the passepartout from our perspective. Yeah. Okay, so moving to topology. So with Zeno, you can do peer-to-peer, and peer-to-peer over a click. Again, a click is a graph in which every node has a direct link with any other node. DDS is an example of a technology that assumes a click, either because you have multicast or because you have to establish session between every peer. But Zeno can do that, can do mesh, okay? So we have application in robotics where the networks are radio networks. On a radio network, you cannot do that because if you are not in line of sight, I cannot reach you directly. So I need an infrastructure, a protocol that is able to relay information, and that's what Zeno does. By the way, if you know in which topology you are going to be, you can actually configure the routing protocol for Zeno. Because obviously, from a protocol perspective, supporting this topology is more expensive than supporting that. That one is trivial. The routing is like really trivial, right? This is a little bit more, I mean, here we have to do link state. There you don't need to do link state. And so in Zeno today, we support 2 different routing protocols, but hopefully early next year, we will release a version of Zeno that supports a routing plugin. So you will be able to put your own routing protocol in your Zeno deployment, if you will, okay? Because we think that that's an area of innovation, and there is no one single routing that fits everyone, right? You can always optimize, as I've just shown you. Something else that we support the concept of a client. Some applications are so constrained that they cannot do peer-to-peer. They cannot relay information on behalf of other applications. And in this case, they need either a router, which in this case would behave like a broker, but for us is a router, that mediates the communication between the clients, or a peer. This looks, again, exotic, but we have application in robotics, oceanographic robotics, where constrained robots pair up with more powerful robots to communicate between each other and other peers. And then in Zeno, you can deploy routers. All of this is software routers, again, written in Rust. And if you've seen the little Turtlebot that we have above, on the Turtlebot, there is a router running, by the way. And the router is running on a Raspberry Pi. And you see the CPU utilization is very low. So it's quite lightweight, our router. So that gives you essentially no topological constraint because you can pick and choose the topology that makes sense in your system segment, okay, which is quite important. Okay, so Zeno run on MCU. Our current Zeno C that is on GitHub, on the Eclipse GitHub, I believe has only 6 or 8 MISRA violations, and they are minor MISRA violations. So essentially it's MISRA C compliant already, which is a big plus. Then, I mean, MISRA, it doesn't always mean quality code. But again, and what I mean with that is that there are certain MISRA rules that induce or reduce code readability, but those can be justified. So we have some justification in our tools because, I mean, I don't know if you've done MISRA, but anyway, that's an entire chapter. If you look through our Rust code base, it's like an oil stain that is expanding. The portion of Zeno Rust that is becoming NoST is growing, okay? We have internally a minimal version of the protocol running on an Arduino board but that's not for everyone yet. It's too much bricolage to get it up, okay? But that's coming, okay? We are working on it because eventually we want to have Rust also on these microcontrollers. So what are the abstractions? Whoops, too much. What are the abstractions that we have in Zeno? In Zeno, you deal with resources, and a resource is a name value. So a name looks like a URI or a path in a file system, and a value, we support some value natively. So in Zeno, you can publish a float, an integer, a string, or composed value, JSON, or just raw bytes. And in Zeno, there is this concept of value that can have attached, if we cannot detect by the type system, a MIME type. And so this is how you can encode the information that is traveling with. We have key expression, where a key expression represents simply a set of keys, okay? And there is a regular language to express key expressions. This language will be evolving because there are more interesting things that we want to be able to express. But you know, this is a very trivial example of key expression in which a single star expands to a single level and double star, like in MQTT, expands to as many levels as you want. And then we have selector, where, and by the way, here I have the old selector syntax. So sorry for that, I apparently integrated an older slide, but the concept is the same. So a selector is composed by a key expression. So this represents the set of the resources I'm interested in. So all the resources that match this key are relevant for this. And then you have a predicate, which is, well, among these resources, I want those for which the CO2 attribute is greater than 12. And for those, please project the humidity. Okay? It's like the sigma and the pi operators in databases. Okay, so then we have three fundamental network abstractions. So in the network, there are these three things that live in a Zeno network. You have a publisher, and I like an analogy with water. A publisher is like a spring of value. Values sparkle out of the publisher. A subscriber is a sink, right? You declare a subscriber for a key expression, and that's what you get. That's continuous data being streamed to you. And then you have a queryable. A queryable is someone that tells, look, I'm a well. In a well, you go with a saw to take water, right? A subscriber is like rain, comes to you. But the difference that you don't decide whether it rains is in fact the sky. But if you subscribe to rain, you get it, right? With a queryable, it's a saw, it's a well. So it says, look, I'm a source of data for this key expression, for instance. So that our protocol, whenever a query is expressed, can do a set cover operation, decide what is the closest set of queryable that covers literally in a set theory, okay, my query and route the request there. That means that if I'm here, you know, maybe Daniela is the queryable that can answer my query and covers completely. But if I'm in another place on the network, like maybe here, right, it's the four of you guys that I have to interrogate because the four of you have an intersection whose intersection with my query, right, happens to be exactly the set of my query, okay? And so, so if you are familiar with a set cover problem, that's what we have to do. It's in fact a super interesting research problem on which there isn't much research, because from a theoretical perspective, some of the problem that we have to solve is a problem of equivalence between finite state automaton. But there are no efficient algorithms to do that way. Okay, that's, yeah? So we have our own algorithm. We have engaged with some researcher, but nobody has found an algorithm more efficient than ours. Our performs quite well because it's in the critical path. Obviously, it's a query, so right, it's not what will take the longer time, but still, it's an important aspect for us. Okay, let's move at primitives. So in Zeno, you have open close to establish and negotiate a session. Plenty of things are negotiated. In the previous session, I explained that things like sequence number can be negotiated. We figure out if you're in the same memory domain so that we can do shared memory optimization, and so on and so forth. Then you have the declare. So you can declare a subscriber, you can declare a publisher, you can declare a queryable. Declaring a subscriber and a queryable are necessary if you want to be a subscriber or if you want to be a queryable, so someone that will answer to query, declaring a publisher is optional. This is an optimization. So you should declare a publisher only for a set of resources that you are publishing very often that allow us to do some optimization. Otherwise, you can write as soon as you open a session. In fact, you can put data without having a publisher. And then you have put, delete, pull, and get. Why do we have a pull? Because when you declare a subscriber, you can tell if you are a pulled subscriber. A pulled subscriber is essentially a subscriber that tells, look, you cannot push data to me because maybe I have a duty cycle for whichever reason. And so what Zeno will do is that, okay, then Zeno tries to get the data as close as possible to the subscriber on any infrastructural node. And then whenever the subscriber wakes up and does a pull, it decides how much data to retrieve and retrieve the data from the closest infrastructural node. Okay, so the advantage with this, you could implement this with a query, but the query always goes to the source. Right? Here, we are really storing the publications as close as possible to you in an ephemeral storage on the boundaries of the infrastructure, so you usually have only one hop to get it back. Hopefully makes sense. Okay, so here there is so let me go to the animation. Oh, well, actually, this point is actually quite important. So if you think about Zeno abstraction, they are universal. In which sense? I mean, in distributed system, typically you need to deal with data in motion, so that is typically used for the data plane, right? That's pub sub, done. We have pub and sub. You have to deal with remote computations, which usually are very useful to represent the control plane. And in fact, queryable give you a way of dealing or representing things that answer query. That could be a computation, okay? And you have to deal with data at rest, storages. But again, a storage, meaning InfluxDB, whatever, right? It's nothing in Zeno than a combination, and we have a plugin mechanism for that, of a queryable and a subscriber. The queryable is the reading part of the storage, and the subscriber is just the fact that whenever there are updates in the system through publication, they are inserted in the storage. Okay? And so all of a sudden, you have one protocol where you can do pub sub, remote computation storage. You don't need anything else. So not only you can use it end-to-end, but it addresses the key problem that you have in distributed computing. So let's see this a little bit in action. Okay, so imagine, I mean, these are cars, could be robots, whatever. Okay, so suppose that you are using either our PaaS infrastructure or you have deployed Zeno router on your favorite cloud provider. And we are using the example of 5G MEC that this could be on-prem, for instance, as opposed to that on the edge of a telco. This could be an on-prem. We support that as well. And imagine that there is the topology. So here there is obviously a publication, and this publication will be received by all subscribers and all storages who key expression match the name of the resource that is being published. Okay? So if here there is another publication, then this publication, notice, is reaching all the subscribers and the storages should reach. And then, actually, it's being stored here. For this subscriber, there is a pooled subscriber. It's stored in the infrastructure, okay? And when the subscriber is ready to consume, we'll consume the data at its pace, and eventually this data will be garbage collected. Okay? Now, suppose I want to get some information for all the cars in the fleet 1. Okay, I can do this query. And Zeno would decide that perhaps the best way of getting that data is querying these 3 storages. Would trigger the queryable, consolidate the data back, and there are multiple consolidation policies, known being one of those, and you are done. Now, suppose you move and you are here. Perhaps the best way to query is to go through this storage. So, and you realize that this way you have load balancing and mobility done for free. You add another storage that does load balancing. You have an hotspot, you add the storage. Our storage are automatically aligned, by the way. And when I say our storages, it's our storage plugin, because once you plug a database, a third-party database, you get alignment at startup and on alignment after a partition. So if the network partitions and you have 2 storage and they diverge, once the network heals, they realign again. Okay, and there is a nice blog that explains our alignment protocol. I think it's quite cool, our alignment protocol. we had a scientific publication on that too, but I think the blog is the good place to start. Whoops, sorry. Okay, computation. So a queryable could represent a computation, and we have had actually some use case like this on edge intelligence for vehicles. So suppose that you want to get some advanced computation for ADAS on some complex image. You could issue a query, and depending where you are, right, that might be the closer queryable. Or if you move around, whoops, oh, I don't have the animation here, sorry. But if you move around, potentially you would have hit that queryable. The same principle applies. I mean, queryable are routed depending on where you are on the graph. There is session migration in Zeno today. The support for session migration, it's, let's say, kind of minimal, but there is support for session migration, both automatic and by administration. Okay, whoops, we're going to re-get the... Oh, here we had two code examples. So here we have a code example here in Python. I was mentioning that you don't need the publisher to produce some data. So in Python, you open a session, and then you just put a key value. And the subscriber, it's more articulated just because that's the declaration of a listener. Otherwise, you have an open, and then you pass the listener asking for reliable data. That's it. And this is in Rust, where in Rust, you see that in this case, we have a stream. You have also a possibility of passing a callback to a subscriber, but we find this is easier to reason about because you have no inversion of control, okay? So that's a subscriber that is receiving data and just printing it out as if it was iterating a container, but it isn't. So that's asynchronous code, but happens to be sequential because of how async code works. And if you write code in production, I mean, I think you should always try to write in this style because it's much easier to reason. As soon as you have inversion of control, your logic is scattered on all the listeners and it becomes a complete mess. Okay, so in Zeno routers, we have a plugin system with a well-defined interface. And as of today, you can build plugin for databases. And these are some of the databases supported. We support Amazon S3 and also Minix. So you also have the open source plugin for databases, for protocols. So for instance, in the robotics community, this one is very popular. They usually drop a Zeno router with a DDS plugin on the robot, and then they use Zeno to communicate R2X because it works better. And if you have an MQTT system and you wanted to decentralize and bring the MQTT broker closer to the source, just start some Zeno router and federate the router in your favorite topology, and you're done. This is something that we demonstrated, I think, last year at the last year Eclipse. Okay, so if we look at performance, this is a paper from NTU. It was published, a peer-reviewed paper published on a conference, and they contributed a blog on our website. But here they compared Zeno, DDS, Kafka, and MQTT. It's logarithmic scale, okay? So for instance, if you look at the throughput in gigabit per second, let's see, we are already 1 gigabyte at 32 byte payload, okay, with Zeno. And if we look at the 10 gigabit, it's crossed already at 512 bytes, okay? And we have peak throughput of close to 70 gigabit per second. That's on a 100 gigabit per second network at 8 kilobyte payload. And in terms of latency, the latency that you get with the traffic, the networking configuration that gives you this throughput is around 10 microseconds because there is quite a bit of network scheduling. If you use the ultra latency transport that disables all that scheduling and takes a slightly different path, is almost half of this, 6 microseconds. And again, that's the first implementation of the ultra latency transport that we just released. Hopefully we'll manage to reduce this even further. And these are latency for other technologies, okay? So I mean, I think it's pretty good. Okay. So for those, I mean, I think it's good to know what was just released. I shared that during the community update, so maybe some of you were there, not everyone, so maybe it will be a repetition for some. But so in the latest release that we released a couple of weeks ago, which is called Dragonite. So just for you to know, all of our releases are in alphabetical order. So, and they always have a name of a dragon, obviously, because our logo is a dragon, right? So the first one, if you go and look at the various names, you can make sense out of them. But the first one was the Merlin wizard dragon, Aitusa, the young white dragon, okay? And the last two have been Pokemon dragon, okay? But anyway, I don't know what we will do for the next one. And we have started also the tradition of sticking the Pokemon card in the office for each release. So I guess we'll continue with Pokemon probably, okay? But anyway, so we have the ultra latency extension, a shared memory transport. We already had 0 copy support, but this is added. Some protocol improvement, and there will be a series more in the next release. Kotlin API, and we have rewritten the Wireshark plugin now in Rust. It's the same code base as the proper Zeno, so no more divergence. And the ROS1 bridge. We already had a bridge for DDS that was used by ROS2 developers, but we didn't have for ROS1. And that's what we added based on requests last year at the ROS conference. So next release, we're already working on, and you already see the evidence of this in the repository, okay? JavaScript API. I don't know if you know, but there was already a way of getting a WASM out of Zeno. We've already used it, but there wasn't a good API. I mean, you just get the code-generated API that is rather ugly. So we didn't, I mean, we are kind with our user. We didn't want to bother you with that. And so we are now doing a proper JavaScript API on top of WASM, which will be quite nice. Android support. Today, we already have Android support committed to the Kotlin repository, but you have to do the building yourself. With the next release, I mean, you will just drop a package into Android Studio and you're good to go, okay? Now, we used to have a regular DDS bridge that was already working very good for the ROS community. But it was a pity because we had done really that bridge for DDS application. And based on how ROS works, there was much more that we could do. So in the end, we decided to build a bridge that takes 100% advantage of ROS, because there are certain naming conventions that we could use to detect that, for instance, a couple of topics are not just to publisher or a publisher and subscriber. It's an action, or it's a request or whatever. And then we could map those to queryable, further reducing traffic and so on and so forth. So we have already announced the early availability of the ROS2 bridge. Julian announced it yesterday. Julian Enoch, maybe some of you know him. And we are going to demonstrate to the ROS conference, so it's already there. But again, officially will be released with the next release. We are still working on some improvement on shared memory support. We need to do that, also part of that as part of the certification, to make sure that all the critical parties in the API or the portion that we certify. And there are some changes we want to do now. We do the distributed garbage collections. So that's already being worked upon. InfluxDB2 connector, MQTT protocol improvements. Our plugin that was demonstrated last year wasn't fully complete. We have added a few more features since then, and with this release, will be 100%, exposing all the MQTT properties. Zeno Pico modularization. So this is really to allow you to pick and choose the subset of Zeno Pico that you want to use, okay? And integration with uProtocol is also coming up. That's based on some requests from the automotive community. Now, I want to actually jump back and give you a few interesting news that just happened. I think this one is the most important. So I think for Eclipse, I think for us being a European company and small European, I think for me I'm very proud of this. Very proud of this because when we started Zeno, people thought that we were kind of either idealistic or completely out of our mind, right? Who starts writing a new protocol from the scratch today? But again, we felt someone had to do it, and we didn't care. We did it, and we have very hard head, okay? And again, there were no necessarily. It's a young protocol, and I think to become the alternate RMW in ROS after an evaluation that looked, because you should, the link will be available in my slides. But if you look at the report, you should really read it because it goes through some of the issues that they've been facing on the last years. They have a user survey, and then they do a comparative analysis. And for us, there were obviously two things that, I mean, we were very surprised. First of all, that the community was asking for Zeno. Personally, I wasn't, I mean, I'm very happy to see that. We always give, honestly, we never ask, okay? But that was a lots of giving back, okay? So, but then the more important for me is this table that you might want to look at offline, because they did, Intrinsics and Open Robotics did a throughout evaluation of all this protocol and compared it to Zeno, and decided that Zeno was the protocol to be the next RMW for ROS2. It's super powerful. And I think it's for Eclipse, it's a super success story. And again, I mean, we feel even more the weight of responsibility, right? Because I mean, this is going to be a lot of responsibility, but I mean, we are there. We love what we do, and we'll continue trying to do good work. Okay, so wrapping up. Let me jump to the conclusion. And in fact, I want to jump to this. So wrapping up, so if you have not tried it, try it. If you have any question, join our Discord. We are super welcoming. And if you like it, then give us a star, okay? It's just a click away, but you know that helps a lot also, spreading the word and making sure that Eclipse technology keeps rocking. That's it. Thank you. Are there any questions? Thank you. Any questions? I literally have 2 minutes for questions. Yeah. Oh, hold on. You need to.
Are there any real-world projects already using Zeno that you have been working on?
Yes, I can show you a few examples. That's on another deck. So we have a few in several different domains. Okay, so this is one in robotics. That's again oceanographic robotics. This is the platform that I was mentioning uses OpenThreadX and Serial. Okay, that's deployed. This is just bridging R2X for existing DDS systems. So one of the advantages of Zeno and the way in which the protocol grew so much in visibility is that as soon as people that were using DDS started having needs to connect these things and let them talk to each other to infrastructure, it was problematic. And we had a solution that was there. The protocol works very well over wireless, and so that was something that started giving us quite visibility. We are deployed with quite a few AMR. So Tractonomy is one example. Unmanned Life deployed, and that's a company that does this kind of drones, and they are controlled over 4G or 5G. For remote area surveillance or monitoring. Flex, that's completely another different domain. They do soft PLC. They have a solution for industrial. And I believe this comes from their white paper in which they justified, and it was very good marketing for us, because they published this white paper in which they explained why they decided to choose Zeno. And for me, the most important, besides the technical advantages, was, this one. It is possible for a very small department at automation company to integrate Zeno with little effort. That's the most powerful, because it could be a super cool technology, but then you have to sweat blood in order to use it. Not very useful. This is super cool application. And by the way, you will see their quotes on Discord, because they love Zeno. So this is there are two things. They're using this for two products. CryptoRat, which is a cryptocurrency, and EverInfer, which is an internet-scale machine learning, distributed machine learning framework that works a little bit like SETI@home. I don't know if any of you recall SETI@home, but you make available, and then you actually earn CryptoRat. So that's why the two are tied. All their infrastructure was built using gRPC. And they switched to Zeno, and the result in scalability, performance, usability, it's impressive. And all the information is on Discord, them selling it, from 60 to 15 times performance improvement. But you go on Discord, you look, okay? My pleasure. And then, I mean, these are the one we can talk about, okay? Yeah. Anything else? Otherwise, I really need to run. But in any case, there is Fanny, there is Daniela, we have a booth, and it was a pleasure to be here, to meet many of you either again or for the first time. So hopefully see you soon. Thank you. Ciao, ciao.